Yeah, so welcome to our meetup for the PowerShell User Group Rhein-Neckar. It's actually the first in 2025, and as you know, we are very happy to have Jakub with us. Yeah, walking us through cover your legacy PowerShell code with tests, obviously Pester tests. So before we get into it, maybe if you're new to our group, Ryan and we founded it a while ago. Ryan, as mentioned, cannot make it today because he's busy with a company event. As you can see, you can reach us on the usual channels on LinkedIn, on Twitter, and okay, there's someone else joining. So if you want to follow us, so obviously you have registered via the meetup page, so you found that already. We're also we also have a page on LinkedIn, on Twitter, and we have a YouTube channel where all the previous recordings are available. Also, the one that we will from Jakub will be available there in a couple of days. And so I'm working for ScriptRunner, and coincidentally also sponsors the user group, so paying for the meetup costs and things like that. And if you are interested in some free PowerShell goodies, feel free to go to our website. We have a PowerShell poster, a security ebook. We have a PowerShell cheat sheet for Teams, for Exchange, and also for Active Directory, and additional white papers. So yeah, feel free to go there if you want to grab some of these free resources that help you in your daily business with PowerShell. So, and with this, without further ado, again, we're very happy to have you with us, Jakub, to tell
Hi.
us and to show us Pester. And you have to you wear the right T-shirt, right? So it's yes, excellent. So yeah, feel free to share your screen and start your session.
Okay, thanks for having me. Let's go. So today I will be talking about covering your legacy code with tests. And legacy here doesn't have to mean super old code, but it just means existing code. So we will be focusing on covering your existing code with tests, because I think that's the easiest way to get started, especially if you already have a project that has some code. So my introduction, I'm Jakub. I own Pester. I also own Profiler and maintain them. I maintain Pester together with Frode Flatten that you might have met on PSConf and might have met him this year as well if you're coming. I work as a senior software engineer at Microsoft, working on testing tools like VS Test, Testing Platform, MS Test, and .NET Test. I don't represent Microsoft here. I have to say that all opinions are mine. You can get in touch with me on Blue Sky, Twitter, also through email if you prefer that. I don't have very strict spam filters, so feel free to send me your questions. Where you will probably not get in touch with me is LinkedIn, because I don't go there and a lot of people message me there and I respond in like a year and a half, which is very unfortunate. So also, if you have any questions throughout the talk, just either raise your hand or start speaking, because I cannot see your raised hand, and you can ask questions as we go. We have plenty of time, I think. So I get often the question, I want to write tests, where do I start? And I think the best way to do that is that you use your existing code and you use it to start learning Pester by adding tests to the code, and you just take the code as it is, you get the results that it gives you, and then you try to bend it into a way that is being tested with Pester. This gives you a nice safety net of your actual code that you might want to maybe improve, refactor, add some more functionality without breaking previous functionality. So having tests is always useful. And you start by adding tests that capture how your code is working now. That's where the legacy comes in, because this is the way to handle legacy code. You cover it with tests, and then you start refactoring. I think it's also important to start slow. Don't set yourself too high goals. Don't think that you will start today and tomorrow you will have 20,000 tests. That will be perfect. Either you will end up with 20,000 tests that don't test much and you just have them for code coverage, or you will not achieve your goal and you will be disappointed. So I think it's much better to have 10 tests in 10 different crucial places of your application or your script, rather than 100 tests in one single place, especially if you generate those tests. And then you have to repeatedly check what is the effort that you had to put in to write those tests, and if those tests are failing when they should. So if they are giving you any benefits. Because if the tests are failing when you are just changing code, then you have probably too many tests and you maybe overspecified your script or your application. If you have problems reported from customers that you think you covered with your tests and the tests are not failing, then maybe the tests are broken and you have to revisit them and see where the problem is. For me, what worked, especially in Pester, is that we add tests to the framework itself to test the framework that cover more rather than less. So we are trying to focus on the public API. So if you have a module, start by focusing on the exported commandlets. Start focusing on how the user uses them, run them, and then on the other side, look if there's anything that you need to kind of substitute or stabilize. If you are connecting to a web API, maybe that's a good place where to put a mock, because you don't want to be calling the API maybe for every single test. If you're communicating with some other commandlet that does some changes in the system, maybe destructive changes, that's probably where you want to be putting your mockings. And in the middle, where there would be unit tests, maybe you don't need to test at all. Because if you add many, many unit tests in the middle, then it really specifies how the code is written. And then every time if you make a change and you have to also fix 20 other tests that are unrelated, then it's not a very good experience. So I hope this makes sense, because this is all the slides that I have. And now we can just go into the code demos. So I will just go and I will close PowerPoint so it doesn't bother me anymore.
Perfect.
And we can start from a first function. This first function is doing convert to base 64. Base 64 is a very simple text encoding. And the feature of this function is that it consumes some text and then it outputs some text. So we can tell about it that it's kind of pure. It doesn't have any other side effect that would be happening inside of it. So you can call it as many times as you want, and you will always get the same result if you're giving it the same data. It doesn't do anything else in the system, and it doesn't consume any other resources to understand what you want. So there's only one path through it, from the input to the output. And those functions, those pure functions, are the easiest to test. So we will start from them. So I will define this function. But first, I ran this setup script, which imported Pester for me with version 6, and it also adds this function called invoke tests, which I'm using to wrap all the tests so I can run them directly from the file. You yourself will probably never need this, because unless you're doing demos, then you will definitely need this. But normally you would call invoke Pester on your test file and it would run the test file, or you would click the button that says run tests inside of Visual Studio Code. My tests are not structured this way, so I'm using this helper function. So just don't be surprised that you don't find anything like this in the Pester module. And so I define this function. And then I have my first test. I call it convert to base 64 in the describe. And describe is a container for my tests. So I need to have at least one describe inside of every tests file. And normally this would be put into a script file that would be called convert to -base64.tests.ps1. And then I would invoke that file using invoke Pester. And that would be my first test ever, if I never wrote anything like that before. And so now I wrote my first test. It's defined as this it, and it says it encodes the string correctly. Not the best name, but we will have to start somewhere. And what I do is that I take this function and I give it some string, copy that, run it in PowerShell, and it will give me some output. Because right now I'm not looking to find bugs or see some edge cases. I'm just trying to formalize how the application is working right now. So I take the function, I run it, and then I formalize it into the script. So actual will be this. That's what I actually did. And the expected result is what it gave me back, which would be this. And then I just need to write something that will fail if those two things don't align. And for that, I use an assertion, and the assertions are represented by should inside of Pester, but you can also use if and throw an exception. They work the same, but the should keyword and the assertions are just putting more functionality under less text, so your tests wouldn't be as cluttered as using ifs and throwing exceptions. So inside of this assertion, I pipe in the result that I got, and I tell it, I want this to be the result. And then I'm using be exactly, because be exactly compares text as case sensitive rather than case insensitive, as PowerShell normally does. I run the test. For me, I'm pressing F8, but for you, it would be invoke Pester or pressing that run tests button. And it passes, and everything is happy. And I just wrote my first test, and I'm starting to cover my application. I already have maybe 1% of code coverage. So now where do we go next? So first thing, encode string correctly, not the best test name. We really don't want to be seeing this in the output when it fails because it doesn't give us enough information about what happened. What does it mean correctly? What does it do? And so it might be better if we add some examples, and so I can do it naively and just copy paste them here in the output and everything will work. I get better name. I'm getting closer to my better test. But I don't know if someone noticed, I made a little typo when copying the script, copying the text. There is this one, and here it says I. So this is not the best thing to do because then your output will not agree with what you are actually testing. So for that, we have templates inside of Pester, and we have this for each. So for each gets an array of items. Those items can be either normal items or they can be hash table. If they are hash tables, then Pester will recognize this as an expansion. So it will take this and it will expand this into a variable and this into a variable, and it will populate this value into this variable and this value into this variable. And then you can consume them inside of the test, exactly how I do it here. But you can also consume it here in this bracket templating language, which on the simplest level, you just put the name in there and it will be expanded to the value that you gave. So let's try that. It runs my test, and now I get the correct value coming from here and the correct value coming from here. So like that, I have my first test and I can start adding more examples. For me, in most cases, I try to use this kind of syntax, even if I have just one example right now, because then it makes it much easier for the subsequent tests to lean on this and add more examples as needed. So if I wanted to write 3 more examples by, again, taking this string, running it with this function, I can just add it like this. And then I can run all my scripts, all my tests. And now I have 3 examples and 3 tests, and all of them pass. And I have better code coverage. I can start adding some edge cases. Usually I also add maybe some comments into the code saying, this is the normal flow. This is some edge case where I'm trying to break it. This is playing with emojis that we don't really expect, but we really don't want to be breaking in this stupid case. You don't need this param as described in the comment. In previous versions of Pester, you needed them in version 4, but in version 5, this is no longer needed, so you don't have to specify it. Less room for error. We just define it for you and you can just directly use it. Any questions so far from the audience?
Nothing in the chat so far. I think everybody's happy.
Okay, perfect. And so we have this first function called convert to base 64, and the functional requirements are pretty clear. It has to grab some text and it has to output some text. But also PowerShell functions have additional non-functional requirements. Maybe we want this to be mandatory. So we want the value to be always provided, otherwise we fail. Or maybe we want this help to be present and start with a standardized thing that says converts this, or this is a function that does this, or there is a link to help in every single function. For this, we have additional things in Pester. So for the mandatory parameter, we have this should have parameter operator on the should assertion. And I can tell it it should have the parameter with the name value, and it must be mandatory. And the input object that I'm giving it is this command object. So I will do get command, my function, and then I pipe it inside of this. And by looking at the description of the function and the metadata, we are able to either pass or fail the test. So I will run it. And it fails because it doesn't have a mandatory parameter. It says expected it to have parameter value, which is mandatory, but it isn't mandatory. So now you have to go and fix it. I will do just that. I will set it to mandatory. I don't have to have the true here even. Re-import the function and run my test again. And now it's passing because I managed to do what the test asked me to do. I set the parameter to be mandatory. Other thing that I might want to validate is that I check the help. And for that, we don't have a built-in operator, but you can add your own. And this is how you would do it. You would register this as should operator. I made a whole talk about it if you want to see all the details. You have to specify those parameters, and those additional parameters are specific to your assertion. And what I want to be able to say is that I say this command has help with this description, convert string to base 64 encoding. So this is the implementation, and I don't want to be putting this in every single test. Instead of that, I want to see this. And you can also notice that I can here leverage the current assertions. So I don't have to, again, re-implement how to compare two strings, how to find something in an array. I can just add my business logic and then leave it off to the additional assertion that's already built into Pester. So let's run that. So we run it, it fails because we have a typo in the help. I expected converts a string to base 64, but I got converts the string to base 64. And you can see that we get this nice arrow, which is coming from the should be assertion. So it really pays off to reuse the built-in assertion that we already have for string comparisons. So those are the absolute basics that we have. And now we can go and look at some patterns, because you probably already have a code. That's the whole premise of this talk. You have some code that you want to cover. And so here are some patterns that you will probably find in a code base that's not super prepared to be tested. And so the first one, oh no, actually, this is not the patterns. This is one thing before. So, but it's very similar. So here we have another function. The function is more complicated than the one before. And here we are calling into invoke web request because we are calling into an API that gives us information about Pokemons. And we want to learn, for example, about Pikachu and make sure that we return a nice object that fits all the PowerShell criteria and extracts the information that we are interested in, like the electric type of Pikachu Pokemon. So I import this function, and now I will go and try to test it. There are quite a few things in here that we can test. And so here you can see that we are kind of normalizing the name to be lower. We are calling invoke web request with the get. We want to be verbose. We then grab the content, convert it to JSON. We could also use invoke REST method, but that's not what my current code does. So I will not change it just to be able to test it differently, because again, we have existing legacy code and we want to maybe refactor afterwards, but not right now. So let's look at the test. I call it get Pokemon, and I say it returns the basic info about a Pokemon. First thing I want to do is that I create a mock for the invoke web request, and I don't give it any parameter filter. I say, if I ever reach this mock, just throw an exception because I don't want to call the real API. First reason is that the API might be paid. In this case, it isn't. But if it's a paid API, I don't want to be calling it just by accident. Second thing is, this makes it much easier to debug problems. So if I just throw, I will be immediately notified you did something that you shouldn't be doing. You are falling down to the default mock. Maybe your parameter filters are not correct. So here's an exception. Then I add a second mock, and the second mock is not default anymore. It has this parameter filter. So if it's fitting this predicate, so if the incoming URI in the parameter looks like this, then I will invoke this body of the mock. So if we scroll back up, in this case, we wouldn't have to filter on this because we have only a single URI. But maybe we have a commandlet that looks at two different URIs, and then we would need two different mocks with two different filters. Or maybe we want to get the data first, do something with it, and then we want to post in the same method or in the same function, and then we would want to filter on the method rather than on the URI. So that's the usability of the parameter filter. You can have as many mocks as you want, as long as their parameter filter matches, and it will select always from the last one defined. So if I would redefine this with the same criteria, I would invoke the second one. And so here we have the parameter filter, then we have the body. What will happen when we execute this mock? And I just recorded this JSON by calling the API, saving it into JSON, saving it on my disk, adding date, because then I know if something breaks, I can compare this file with what the API is currently returning. Because every time you add a mock, you are kind of disconnecting yourself from the real world. You're not paying money for calling the real API, but on the other hand, you are not getting the real data. So if the API changes, if there is a big breaking change, or if it's broken in some other way or improved, then your tests might not be failing. And that's why you also need to have like a suite of additional integration tests that you might not be running every single time and not testing 1,000 items in them. But this allows you to isolate yourself and test small details and small edge cases. I take this content, I just add some status code and the content and return it back because that's what the invoke web request does. And then I tell this is what I expect to get back. And then I can just call my function. So I will call get Pokemon. That will eventually reach the mock. It will process the data, load it from the file, and then I will be just validating that I did this processing correctly. So I'm testing mostly this part. And so let's run the test. It's pretty long. So I will select all the text, run it, and fingers crossed, it passes, which is great. And if we look at the assertions, we had to do quite a lot of work to ensure this object is correct, which is pretty annoying. So in Pester 6 and previously in my assert module, I have this should be equivalent assertion. So I will go ahead and I will uncomment it here. And the advantage of the should be equivalent assertion is that if I go to my expected data and I will add additional requirement, like that the color of the Pokemon has to be yellow, and I forget to add it in here, then none of those assertions will fail. And especially if I have more complex object that has sub-objects, that has collections, and so on, it gets really difficult to make sure that you test every single thing that you want. So the easier way is to provide what you expect, ask the API, return the result, and then just call the should be equivalent on it. So now I will rerun the test and it should hopefully fail. Yep. So if we look, we passed all of those assertions because those are still the same. And then we failed here in the should be equivalent because it says the actual and the expected should be the same. And we just exclude every single path that's not on the expected. So if the incoming object has more data, we ignore everything except for this, because this is our specification. And then we can also look at the error because the error is pretty amazing. It tells me this is how the expected object looks like. This is how the actual object looks like. And here's the summary of what was the difference. So the expected has property color and the actual object doesn't have that. And you would get this summary and this overview for every single thing that's there, even if you have additional objects, even if you have arrays, hash tables. I think I handle a lot of the objects that you can. And also it's formatted so it looks nice and can be readable. So I think this is really, really useful if you have some kind of API tests to write, and saves you a lot of time and gives you a lot of confidence in your own code actually doing what you think it's doing. And so this covers this test. We could go forward. If we're capturing this data and maybe we are working against an API that we don't know, a good idea might be also write this code as in form of tests, especially if you have this should be equivalent. You can write some tests and you can get the data as expected. And this way you could formalize how the API works right now. You probably don't want to regularly rerun those tests because you would be paying for that API, but they give you this kind of safety net where you can run them when something breaks. And that way you check, is the API the same as what I expect? And if it's not, you will get a failing test and you will see where the problem is probably. So you will see where the data differ. Another option would be to save the content into JSON files and then compare them, or similar things, but this is one of the options that I used. And you also probably want to have some happy path tests, integration tests that you will run against the real API. So if the real API changes, you will know about it before your customers will tell you, well, this is broken. And you will say, well, all my tests are green. It's because you're using mocks. So have some real tests against real API as well. Eat that cost. And then the nice thing about testing stuff like this is that we're just touching the entry point. Not this one. This. So we're just calling the get Pokemon. And then on the other side, we are kind of outside of the function almost. So we are not looking at many of the details that are internally. And so we can refactor. If I wanted, well, not in this case really, but if I wanted to change this for invoke REST method, I would have to change my tests. But if I wanted to change some other small detail in here, I don't really have to change many tests because we're not testing how exactly we are converting, how exactly we are making the object. Those tests usually are pretty useless.
Jakub, we have a question in the chat. I can read it to you.
I can read it as well.
Okay. It's about the different versions.
From Pester 4 to 5, there were a lot of breaking changes. I wonder that is in Pester 6 release. I missed unit test for all my projects, had a lot of struggle in my last large developments with debugging, so start to do with Pester. What do you recommend? Directly start using 6 with small tests for the beginning. Yeah, so between 5 and 6, there will be very few breaking changes. They will be mostly cosmetic. But it might also take a long time until we are finished with Pester 6. But the main thing in Pester 6 is that we're adding a whole new vocabulary for the assertions. So rather than doing should space and then the parameter like should space dash b, there will be separate functions for the assertions, and they are re-implemented. They are mostly ported from the assert module that I wrote with some improvements. And one of those is also the should be equivalent that we see here. So if we look here, you can see should space B. That's the old syntax. That's the current Pester 5 implementation of assertions. And here we have should be equivalent as a single function, or you would also see should dash B. That would be new implementation for Pester 6. So unless you start using those, you shouldn't get any breaking changes just yet. And then we will add few more. One of them will be if you provide a collection that is empty, do the for each that we saw somewhere here, I guess. So here, if you provide an empty collection, which especially can happen if you have some kind of function that figures out from a file the examples, then the test will fail. Now it doesn't fail, it just doesn't run. So that's one breaking change that will be probably impacting a lot of test suits, but for the good. Other than that, I cannot think about anything why you shouldn't be using Pester 6. It's a very different release from 4 to 5 because we want to do some breaking changes, but we want to do small breaking changes, and we will not rewrite how the whole runtime works anymore.
Okay, thanks.
Perfect. Okay, so that's the example for calling the function inside a function. We will get a little bit back to that afterwards, but this is the basic usage of mocking. Now we go into the patterns. And so the first pattern, we saw that in example number 1, and that's the kind of pure function that consumes input and then gives you output. And the way to test it is really simply just call the function and then do some assertion on the output or assertion on what it does. So here we have reverse string. I give it a string, we reverse it, and then I give it 2 examples. Here I'm using dash test cases, but that's the same as dash for each. This is just an alias for that. And I call this and I get 2 examples, both of them passed. And you can always also say you should probably put the data here in the name. And of course I should do that. So you can do that as an example afterwards. But this is the most usual test in code base that is kind of doing things that are nice like this, or that is already prepared to be tested. Because then you tend to isolate things that are kind of pure from the other things that are not so pure, because the pure things are much easier to test than the unpure things. But life is not always perfect. Sometimes we have stuff like getDate. GetDate is very hard to test because it's very unpredictable. Well, predictable, but very unstable. You cannot really say, I run this test and the date will be this, because then you push it to your CI pipeline and the date is different. And so how do you write that into a test? You have to somehow stabilize that dependency. And in Pester, you will do that through mocking. And so that's our second pattern. We have a mock and then we assert on an output. So we are changing or stabilizing some behavior of something, or we are giving data, maybe throwing an error from something, and then we consume that, process it in some way, and then we do some kind of output. And on that, we do an assertion. An example of this here is this get formatted date that helps us format date the correct way. And we want to test it. So we could also input the date and then process it, but we don't do it here. I don't know why I have this date parameter. And so I will go and invoke those tests. And the test passes because we have a mock. So this mock says replace the get date. And when I'm asked to run, you should return this value. It's returned, and because this mock body is invoked in the same scope as the script, it will be able to consume this variable. So this variable is inherited in here, and we return it. Then we call the get formatted date, and we output that. I think this is broken because it should be like this. Let's see if that still doesn't break the test. Okay, well, I don't know what I meant, but I will fix it and maybe post a fixed code example. But the idea still holds. So we have get date, we call it, we get the mock, we enter this place, we return this date, and then we assert that the date that we returned is the correct one, and it's formatted as we expect. Now, it's not always this ideal. This is probably the easiest way to get the data externally to the mock, but sometimes you need to also figure out the data from the incoming parameters. And this mock body will define all the same parameters as the initial command that has. So this one, for example, takes dash date. And so here you would also have dash date. So maybe you want to calculate it from that. And your first instinct might be, I will just go and I will just call get date. And this won't work. We will run it. I will comment this out. And we will get a Stack Overflow exception or script call depth exception because we enter this mock body, we resolve this command to the mock, we enter this mock body, resolve this command to the mock, and so on, until we reach the call depth and it blows up. So the way to actually do it is by grabbing the original commandlet, because mocks work based on aliases. So this getDate will be defined as an alias. PowerShell will resolve aliases before functions and before commandlets. And so we will call the alias offload to a function that we generated on runtime and then implement the whole mocking. So if we want to call the original getDate, we need to get the command getDate, not forget to specify this command type commandlet, and then you can give it some data, maybe also data that's depending on the input. So you will be able to variably call some additional commandlet and return the results after modifying them and stabilizing them. For example, testing an API, you might want to call the real API, get it back, and fix all the dates on it so you can actually test it. But this is also a very useful pattern. So one that I prefer if I have the data more stable. I just need this to get something original that looks like the object that I want to output. Now our third pattern is the opposite. We have some input, and then we have some behavior that's happening based on that input. In this case, we are renaming my computer to a new name, and the new name has to be to upper. You can also imagine there is some other pattern, like we want to always suffix it with -pc if it's a desktop. But I don't want to rename my computer every time I'm running my tests. I also don't want to restart my computer every time I'm running my tests, and I wrote many functions that use restart computer commandlet. So how do you test that? How do you test it without restarting your computer in the middle of the test? And for that, we are using mocks again, but this time we are replacing with an empty mock, because what we will do is that we will use an assertion that will just check if the commandlet was called with the correct parameters. And if it was, then we just believe that the right action will happen as a result of that call. So for example, if I call rename computer with the correct parameter, it will in the end actually rename the computer. But I don't want to really do it. So the mock here, we define it here on line 61. It doesn't have anything else. We are just saying mock this function and do nothing if we call you. And then I call my function set standardized computer name, set it to my PC. And then after that is called, I want to check the rename computer was called correctly. So I say should invoke. That's an assertion that communicates with mock. This function should be called exactly once. And the new name parameter should be my PC, but capitalized. So the CEQ is case sensitive EQ. We run that, and it passes, which is really nice. Now, if we don't get the parameter filter exactly right, it might be a bit difficult to debug, because it's not going to tell you you were trying to call this mock, but the mock was not there. It didn't have this behavior, which is probably going to be another breaking change inside of Pester 6. We will just remove this default mocking that will call into the actual function. Instead of that, we would throw an exception probably. That's a more reasonable behavior that we saw at the beginning with the guard mock. Another great thing to add would be to show a list of what was actually invoked, which we can probably do after we do this breaking change. But until then, you can use this output diagnostic, which is also available on your invoke Pester. And that will enable the diagnostic output in Pester. You would also see the same if you would go to a test in Visual Studio Code and you would click debug test. It will change the output to this diagnostic output, and it will show you all the information about the execution in this colorful output. So here we have some info about the discovery, and here we have all the info about mocking, including what behaviors we found, what are the defaults, what are the contacts, how did we call it. So for example, here we are running this mock filter, new name, CQ, myPC, and the context, the incoming data from the parameters is this. And so this evaluates as true. And so the filter passed and we use the mock. If we changed it, it wouldn't pass, and we wouldn't use the mock, but we would see the information here in the context, and we could deduce from that why it didn't work. So this is a tool that's pretty useful when you are debugging some mocks. And then the last pattern is that we have two things that already do something, and in the middle we want to do some output. In this case, we want to do something like this: get content from a file, add a smiley face after every single line, and then set the content. Here we need two mocks, one that's producing the data and one that's consuming the data. And so we have this one, so we know where the content, what the content is. Then we process it in our real function, add the emoji at the end. And then we have a set content mock. And then we invoke on that, saying we want to see it called exactly 4 times because we have 4 items. And every single item should look like this. It should have emoji at the end, and it should be trying to save into this file called doc.txt. And again, we can run it, and we see that this test passes because it's correct and we did everything correctly. If I will remove the functionality, it will no longer add a smiley face. And I will see a failure that says I wanted it to be called 4 times, but it was called 0 times. So maybe we can look at the diagnostic output. Just to make it a little easier to find, we can add, oh no, what am I doing? A different emoji, like an avocado. Call it one more time. And then we can look at the output that says I'm running the mock filter for the first item. The path, this is the content of the filter, and the context is this. So this is the value that I got, and this is the path parameter and its value, and it returned false and it didn't pass. And then we will see the same story for the rest of the values. So this avocado didn't match this smiley face, which is false, and this way none of the mocks actually ran, and that's why I got 0 executions. Sorry, that wasn't exactly true. The mock was executed because the mock itself doesn't have any filter, but then we filtered on the executions and we didn't find any of the executions that would match this filter. So the mocks executed, but the filter didn't find what we were looking for, and that's why the assertion failed. Some questions already? We're getting more advanced.
No questions, no.
Okay, well, hopefully all of this was clear. Don't save, just keep it broken. So now we're going back in time, and rather than using rename computer to rename my computer, I can use this WMI object that I grabbed from the system, and then I can call a method on it called rename, and that will rename the computer. And then we return true when the return code is 1 to make sure that we are correctly processing the rename. You probably don't want to do this on your own computer, but maybe you have a different thing that consumes some object and you call some method on it. So I want to show you how to mock this, how you can test stuff like that. And for that, we need a little bit of setup. So we want our implementation of the rename function. What will happen when we call the rename? And that's this script block. What we're just doing here is that we are defining something that looks like this. So it's rename. It takes one parameter. The parameter is name, and that's what we have here. When we get this parameter, we will save it into the current object, into the name property, and then we will return the success value, which is 1. So it's kind of trying to do the same thing that this would do without renaming the computer, having the same signature, returning the same value, and at the same time, keeping the value saved so we can do assertion on it afterwards. Then we prepare this object, which will be representing this Win32 computer system object that we saved here. We set name to be empty, and then we add this method, a script method defined from this rename. So we are getting closer to how this looks. We will have some object that will have rename on it that we can execute. And then we create a mock for getVMI object or WMI object, like we do here. So we actually get this O object from that mock. And that mock object is not going to be the real WMI object. It's going to be this object with the method attached. And then we can just happily test it. So we call the method, give it the name, it will call in here, call into the rename, save the value in the object that we returned. And because we created it outside of the mock, as I've shown you before with the getDate, we still have access to it. So we will end up being able to assert that we actually called it with myPC. This might take a little bit to wrap your head around, but in the end, it's quite simple and it's only useful sometimes. So maybe you don't really need to know it, but it's good to know that it's there once you actually need it.
We have one question, Jakub.
Are there any frameworks and generators that would generate generic tests for existing code, like boundary type tests? I don't know. I don't think there is one. Probably you can write one. I know there are tests for help, like pre-generated tests that can check every single method and its kind of properties and how it works. But I'm not aware of any generators that would generate tests just like for anything. I'm also not sure, boundary type tests, do you mean like my function should be returning this in this array, and those are the expected values that I expect, or what kind of test would you want this to be generating?
Yeah, also feel free to unmute yourself if you wanna talk about it.
Okay, or we can discuss it afterwards at the end.
Okay. Good.
Okay, yeah, so this is the pattern where we grab an object, add a method on it, and then we return it, and then we can assert on the actual call. So this way we make sure that we actually called the method and we called it with the right parameters. It's a variation on the previous pattern where we have the input and then we are calling a mock. In this case, we are again having some input. We're calling a mock, but additionally, we need to also return some behavior. That's the one for us. So if we didn't return this, the rest of the function would think that we failed to rename our computer, and we don't want that because then the tests would never pass. Moving on to .NET types. So for .NET types, it's a little unfortunate we don't have any kind of fakes for PowerShell that we could use, so we cannot really substitute static methods on objects or static properties on objects. So the only way to test it in PowerShell is to wrap it inside of a function. And these days also not calling native APIs in .NET has the advantage of not being hit by MC and real-time scan, I realized recently, so it might be slightly faster to use commandlets. But in this case, I have this datetime now. I cannot really mock that in any reasonable way, so I have to add a mock for getDate and use getDate, or I have to wrap it in a function like I'm doing here, even though new GUID actually exists. So I would wrap it into new GUID too, if I would want to do it like that. And so just want to say that we don't really have any way of replacing .NET types, which is quite unfortunate, but also quite good because then you don't get hacked as easily. So just to run this to confirm that it still works, we have validated that we can replace getDate, but we couldn't really replace datetime now. Next one talks about testing inside of module scope. And so this is a very frequent gotcha that you will see if you will start testing modules, because Pester, if you're mocking, offers you two ways of injecting a mock inside of a module. So in this case, I have this M1 module, And inside of that, I have this get greeting text. And this get greeting text is not exported. As you can see here, we just export the get greeting. So that's the public API. But maybe for some reason, I want to replace this get greeting text because it gives me kind of a good theme inside of the module. I want to be touching this internal function because that's my maybe gateway to an API, and I want to replace that. So I want to reach inside of that module, replace this function with a mock, and provide my own data because that helps me to test all of this other logic that's around it. And so to do that, I can define a mock, and I can do it in two different ways. First, I import the module, and then I will invoke those tests. Some of them should fail. That's right. And then we can inspect why they failed. So first one, we can test get greeting. That's just invoking the function and getting the standard output. So we are getting here, and we are actually calling this function, getting this string, and then we are validating it. No surprise there. Oh, come on. This one and this one. Good. Maybe side by side. That's perfect. So we're calling this, we are entering here, and we're just getting the expected result. Now I want to be replacing this with a mock, so I just define it. And I want to say, instead of hello, I want to say I love the input text, and I want to get I love Pester. And that fails in here, because we didn't reach inside of the module. Instead of that, we try to define the function, the mock, in the current scope, which is outside of the module, which is in our script execution scope. And so we have to either specify module name M1, because that's where the function is being called. So we reach inside of the module M1, and we replace the function there. So that's this text. And this is the recommended way to do it, by specifying the module name on the mock. We also have this write host here, which says where we are executing. And then we try this and it passes. So that would be this test result. So here we don't see any output because we are not executing the code inside of the module. We are in the script scope. So this is defining to the module, but the test itself is running outside of the module. This might be important because if you make a typo and you have this function actually not exported, if this was running inside of the module scope, you would still be able to run this function, even if you didn't export it. But if you do it this correct way, if you forget to export this function, then it will fail. It will tell you, I cannot find this function. It's not exported from any module, and you will be highlighted that you have a problem with your export module member or your PSD1 definition file. The second older way to do this is by calling this in module scope, which will just take all the code of the test and it will run it inside of the scope of the module. This is, again, not recommended, because then you will define the mock inside of the module, but also all the other code will run inside of the module, as we can see evidenced here by the module printing the name of the current module, which is M1, which is this module that we are currently executing inside of. And then we call getGreeting, and the test still passes, but we don't guarantee that this getGreeting function is exported because we are running inside of the module, and it can also have other side effects. So if you can, do it this way.
Jakub, we have another question in the chat from Gabriel.
What does it say? I learned Pester some years ago in CI pipeline DSC blueprint. I only used test files. I see in your demo you can implement it directly in flow of code. What do you recommend? Using Pester directly in code, own checks, if else, do while, or separate test process with test files? I think you will recommend a mixture. I think separate tests from code is the way for me. Yeah, so this is demo code. This is where I'm using extensively this this functionality of Pester that I implemented mainly for being able to test it easily, which is we can grab a container, and typically the container would be a file that has your tests, and you would keep two separate folders. One of them would be for your source, and the second one would be for tests, or at least you would have your script files, and then next to them you would have your test files that would be separating tests from the script. So I wouldn't recommend you in any production case writing the code directly together with the tests. We don't even have a good way of separating them then in the future. This is for the demo purposes. Sorry if that confused you, but this just gives me a very easy way of invoking and changing the code in one place, having many examples in one place and running them one by one without having to set up and resave and so on. So definitely split your tests into files as you like. That's the way to go. You can also name the files differently. There is a configuration in the Pester configuration object, which allows you to change the suffix. So it can be also .tests and .integration test for your integration test. And that way you can also separate whichever test you want to run and which test you don't want to run. You don't have to use additional filters, folders, or tags. Where was I? Oh yeah, the last demo. So you learn how to cover some of your code, and you probably want to go to management, or you want to double check yourself that you're actually covering some stuff. And for that, we have code coverage built into Pester, and you can also install the Coverage Gutters extension to VS Code. And so if I will set it up like this, and I will run the script, then hopefully the test will pass, and I can just go here and do toggle coverage, and I should see it in the file. Do I? Which one do we import? Get greeting tests PS1. This one. And it doesn't work. Why, oh why? It's the wrong file probably. Get greeting tests. This. Okay, there must be some bug. It should give us like really nice green output in here. Maybe it's because I'm substituting the file to X and it doesn't understand what's going on. Let me quickly try it. If there are more questions, please
No, not at the moment.
post them in the chat. How do I call it? This, open in VS Code. So this is the same thing, but without substituting the folder. And I should be going to this one and to this module. Let's see if that works. Yay! So that's what I wanted you to see. By using this simple setup and this extension, you can get live code coverage inside of your Visual Studio Code, so you can double check which test you actually covered and which test you didn't cover, and get this nice overview. Also, you can use code coverage to set up your coverage goals. You can use it as a report for your management, because code coverage is a very useful metric for reports and for progress and so on. So this is how you can do it with the benefit of seeing it also inside of VS Code. And with that, that's everything that I have. I see that I covered a lot more time than I actually expected.
As it
So if
always
there are
happens, but that's great.
any questions, please let me know.
Yeah, there is an additional one now. Can you see it, or should I read it to you?
Which one?
The
That
last
where
one?
we talked about
Yeah,
Pester 4 and
Gabriel.
Pester 5?
Yeah.
Okay, yeah, I actually answered that earlier, but to reiterate, there are no big planned breaking changes between 5 and 6. So definitely go ahead and use version 6. What's added there is the new assertions, like the should be equivalent. We will do some smaller breaking changes, like making sure if you provide empty collection to for each on it or on describe or on the script, we will actually throw an exception rather than silently not running anything. Also, probably the default mock will not run the command that you are mocking by default, because I think that only confuses people and it's not very useful. Actually, I never heard about anyone using it for useful purpose.
All right. I see some people. Okay, Andy, you want to unmute yourself for a question?
Yeah, probably I can. Jakub, thanks for the presentation. Very useful for me, even if I'm still struggling with this testing thing. Maybe I'm not patient enough for writing tests. That should be an AI thing, I suppose. I always ask myself how does this code coverage rate comes into play? So how is this measured? What's the way and what's the number of 100% code coverage? So I'm always ask myself, how can
So
I
are you
test
more
the
interested
function?
about how it works technically, or what should be your goal, or
Uh,
what exactly would you like to know?
more or less both. How can I ensure I'm testing a function in its generally 100% code coverage case? How do I write or how is it possible to capture a function particularly so not in the full coverage? I don't get this concept.
Yeah, so the code coverage itself is useful for seeing what you covered. If you write tests that are bigger than unit tests, you will generally end up writing tests for like a happy path for how you normally use the application. Then if you get into writing tests like this, you might get issues reported, for example, on your repo. And if you get into habit of grabbing those issues and making them test cases that you would add to your test suite before you fix the problem, you will be growing and growing the code coverage of your code. And you would be reaching, I don't know, maybe 70% coverage, let's say. This is a good practice, I think, to increase the testability and the usability of your code as people actually use it. And then if you want to go higher with the code coverage, then you might find either code that no one uses or code that is very edge case that you don't really know how to reproduce. And that would be the rest of the code to fit the 100%. I don't think 100% code coverage is a great goal. If you will go and try to achieve it by unit tests, it might be better to just not achieve it at all. So something like 70, 75%, I think, is generally enough. What we don't show probably in Pester and that we could show is how many times you are going through which code. So rather than showing you how many percent you covered, we could show you those lines are the most covered by test. So they are covered and they are covered 100 times in your test suite. And those lines are covered, but they are covered like 2 times.
Yeah, so
So
you're
that
talking
could
about
help
the
you.
execution iteration, how often a sub-function or a function or a part of the code is executed. Yeah.
Yeah. And so the code coverage is useful as a metric. It's not useful to go to 100% because I think you will end up over specifying the code by unit test just to reach it. but it can help you find edge cases that you didn't test and that you might think are important. Like if I'm inserting null here, will it fail? But if I'm inserting null here and nobody reported that problem in 2 years, is it even necessary to have that code? Probably not. So I will delete it and make sure that I cannot insert an empty value into this place because it's only complicated my code. Hope that answered your question. If you want the whole talk on how it technically works, I can also give one.
Yeah, probably not today, but this might be an interesting one. I have one more question related to VS Code, and even your name's not Justin. Probably you can tell something about. There is this Pester integration in VS Code, and as I understood, the tests are running in real time. Are you using this extension, or can you tell how this is probably works? So how does it find the test files, and how is it executed in the background?
Yeah, do you mean the one from Justin? Because there are two ways of running tests. So one of them is inside of this test view, right?
Mhm.
I don't have any view here, but that's what Justin wrote as an integration.
Mhm.
I don't know what kind of detail you're looking for, but the discovery works normal. As the normal discovery, there is just additional plugin inside of Pester that sends data as JSON to the extension. And then inside of Visual Studio Code, you just have to communicate with the responsible service to populate the tree of the tests. And then when you execute the tests, I think he just sends back a list of things to run, and we run them as we normally would. So rather than, or maybe he's sending whole files. So it's not very different than running normal tests, but the interactive experience is really nice. And I hope Justin will not kill me for saying that. But I think it's really nice, and we should invest more time into making it perfect. Unfortunately,
Okay.
I don't have that time. Maybe Justin does, but
Yeah, probably I should wrap my head around this topic a little bit more. Yeah, I'm not into.
definitely go and use it and report the issues to Justin's repo for him to fix. He will love to see it.
Okay. Okay, thanks.
We have another question from Thomas in the chat.
So that one, is there a transition table for V5 to V6 for commands like should be? One guy, which I cannot now remember his name, but he's wrote a script to do this automatically. I think you can find it in the repo. I will try to find it afterwards and post a link here. He also keeps us in check with what we are doing differently from the previous ones. So if we will go and publish Pester 6, we will include something like that or include a table of moving. But generally, the names are the same. There is additional behavior that you can use, for example, for string assertions, for numbers, for time, for ranges. Then there's also the should be equivalent. Pretty much what I'm trying to do there is that we have a set of assertions that are more open. So you can assert like many things, but also assertions that are very specialized. So if you want to be comparing strings, you want to be comparing just strings. So you want to make sure that you are able to say this contains this other thing, or we don't care about the spaces, or we don't care about the spaces at the beginning and at the end, but in the middle they really matter. Stuff like this that you would have to code yourself in multiple lines of code, but this way you can just get it directly. Or if you measure some time, you want to be able to say this happened after this other thing happened, or it happened inside of this time range. So that's why we needed to stop using the parameters, because those parameters are limited to just 32, I think, assertions, because there are only 32 possible parameter sets in PowerShell. And so we move to functions, and now we can have as many assertions as we want, and that's why we can have this boom of specialized assertions rather than having should be that can act on collections as well as on objects, and then it's confusing about what it's actually comparing. The extension that I installed for the code coverage is called coverage gutters. This one.
All right. Cool. So are there any more questions from the audience? Doesn't look like it. So that was a real great session. Thanks a lot again, Jakub, to take the time.
Perfect. Thank you for having me, and thank you for inviting me, and for all of you to come here and listen to me talk
and
about
also,
Pester.
And thanks for the questions. So it was kind of interactive, which is always cool. So you're not just talking to a wall, right? So it's that was really cool. So again, thanks everyone for joining. Thank you, Jakub, for sharing your knowledge.